titration, acid-base titration, and how to do titration calculation. Firstly, let me teach you some key concepts like concentration of a solution, which would help you a lot to understand the concept of titration. Well, the number of particles of the solute dissolved in a given solvent is called concentration of a solution. For example, consider sugar and water. Sugar is a solute and water is a solvent. If you add more and more sugar to the water, sugar solution becomes more and more concentrated. It is because you add more and more particles of a solute. Hence, you increase the concentration of the sugar solution. Remember that concentration of a solution is expressed in terms of molarity. Now, what is molarity? Well, the number of moles of a solute in 1 liter solution is called molarity. Let me repeat it. The number of moles of a solute in 1 liter solution is called molarity. Also note it down that 1 liter is equal to 1000 cm cube or 1 liter is equal to 1 dm cube. For example, consider 2 mole sugar in 1 dm cube water. Here, the concentration of sugar is 2 mole per dm cube, or we just write 2m. Secondly, consider 3 moles of salt in 1 dm cube of water. Here, the concentration is 3 mole per dm cube, or we just write 3m. Thirdly, consider 10 moles of potassium hydroxide in 2 dm cube of water. Can you guess the concentration of this solution? Well, we divide the number of moles by the volume of solution. So the formula of molarity is number of moles divided by volume. Our 10 moles upon 2 dm cube is equal to 5 mole per dm cube, or we just write 5m. Thus, by this way, we can easily calculate the concentration of a solution. Now, what is titration in chemistry? Well, a process in which a solution of known concentration is used to determine the concentration of an unknown solution is called titration. For example, consider sodium hydroxide solution and HCl solution. Let the volume of sodium hydroxide taken in this object is 50 cm cube and its concentration is 0.1 m, while the volume of HCl taken in this object is 30 cm cube, but its concentration is unknown. Now listen carefully. This is a solution of known concentration. It is called titrant. Let me repeat it. This is a solution of known concentration. It is called titrant. While this is a solution of unknown concentration, it is called inhalate or titrant. Let me repeat it. This is a solution of unknown concentration. It is called inhalate or titrant. In titration, we use this solution of known concentration to find the concentration of this solution. This whole process is called titration. Also, you should learn about the main instruments used in the titration. The primary instruments used in titration is burette and the other one is conical flask. In burette, we take the solution of known concentration like sodium hydroxide, which is also known as a titrant. While in conical flask, we take the solution of unknown concentration, which is also known as the inhalate or titrant. Thus remember that we take titrant in burette and we take inhalate in conical flask. Now what is acid-base titration? Well, a process through which the concentration of either acid or base is determined is called acid-base titration. For example, consider 30 cm cube of HCl solution in conical flask. If I ask you, find the concentration of this 30 cm cube solution of HCl, how can you find it? Well, I take 50 cm cube of sodium hydroxide solution in burette, which has 0.5 molarity. Also, we know that acid like HCl reacts with base like sodium hydroxide to form salt plus water. So we would react acid HCl with base like sodium hydroxide. Hence this whole process is called acid-base titration. We know that the volume of HCl is 30 cm3. Its concentration is unknown. The second step is to add few drops of indicator to conical flask or inlet. The indicator will show us the end point of a reaction between base and acid. I take indicator like phenolphthalein. The third step is to note down the initial volume of titrant, sodium hydroxide and the burette. We can see that the initial volume of titrant, sodium hydroxide is 50 cm3. The fourth step is to start adding the titrant, sodium hydroxide to the inlet, HCl, until the color changes. For example, when we add sodium hydroxide to the HCl, they will react together and the color of indicator would change from colorless to deep pink. This color change indicates the end point or completion of acid-base reaction, and we would stop further addition of titrant, sodium hydroxide to the acid, HCl. The fifth step is to note down the final volume of titrant. For example, the final volume of titrant is 30 cm3. The last and the sixth step is to find the volume of titrant, sodium hydroxide, used to react with inlet HCl. For example, the initial volume of titrant was 50 cm3 and the final volume of the titrant is 30 cm3. So always subtract final volume from the initial volume. I mean 50 cm3 minus 30 cm3. Hence I get 20 cm3. Here, let me teach you one of my favorite questions which I often ask. What is meant by this 20 cm3? Can you guess the answer? Well, this 20 cm3 means that 20 cm3 solution of sodium hydroxide react with 30 cm3 solution of HCl to neutralize it completely. Thus noted down this important point. Now the final step is titration calculation or find the concentration of HCl. Firstly, I write the chemical reaction. Sodium hydroxide plus HCl react together to form sodium chloride plus water. Secondly, I balance this chemical reaction. If you do not know balancing chemical reaction, watch our video and its link is given in the description. We can see that this chemical reaction is already balanced. In the previous slide, we know that 30 cm3 solution of HCl is used and 20 cm3 of sodium hydroxide solution completely react with it, having 0.5 molarity. So I write here, volume of sodium hydroxide is 20 cm3, volume of HCl is 30 cm3, and the concentration of sodium hydroxide is 0.5 m. Here I write known concentration and here I write unknown concentration. The known concentration is sodium hydroxide and the unknown concentration is HCl. Firstly, I convert the volume of sodium hydroxide to dm cube. I write 20 cm3 divided by 1000. I get 0.02 dm cube. Then I find the number of moles of sodium hydroxide used, which is equal to concentration into volume. The concentration of sodium hydroxide is 0.5 m and its volume is 0.02 dm cube. I write 0.5 into 0.02. So I get 0.01 mole. The 0.01 mole of sodium hydroxide has reacted with HCl. On the other hand, I also convert the volume of HCl into dm cube. 30 cm3 divided by 1000. I get 0.03 dm cube. Now listen carefully. 1 mole of sodium hydroxide react with 1 mole of HCl. So the ratio of number of moles between them is 1 to 1. We know that 0.01 mole of sodium hydroxide has reacted I write here 0.01 mole. The ratio is 1 to 1. I also write here 0.01. So the number of moles of HCl reacted with sodium hydroxide is 0.01 mole. Now we can easily calculate the concentration of HCl. We know that concentration is equal to number of moles upon volume. The number of moles is 0.01 and the volume of HCl is 0.03 dm cube. So we get 0.33 moles per dm cube or 0.33 m. Thus this is the concentration of HCl. I hope that you have learned all about the titration.